Hey there! Thanks for stopping by. Let's dive into something amazing together. Welcome to Next Gen EduBuddies. Don't forget to hit those buttons below to stay connected. Like, comment, subscribe. Let's keep exploring together.
The Aurora Borealis is a natural light display in the sky, primarily seen in the high-latitude regions. It is also known as the Northern Lights. Auroras result from disturbances in the magnetosphere caused by solar wind. These disturbances cause the charged particles to precipitate into the upper atmosphere. The ionization and excitation of atmospheric constituents emits light of varying color and complexity. The lights are typically green, purple, and red. Earth's magnetic field is a protective force field surrounding the planet. This field is generated by the movement of molten iron within Earth's outer core. The magnetic field deflects the majority of solar wind, a stream of charged particles emitted by the Sunday. Auroras, also known as the Northern and Southern Lights, are a visual manifestation of this interaction. Charged particles from the solar wind are guided by the magnetic field towards the polar regions, where they collide with atmospheric gases, creating the colorful light displays. The sun continuously emits charged particles into space. This stream of charged particles is known as the solar wind. The solar wind carries energy away from the Sunday. This constant emission represents a continuous energy release into the solar system. Solar flares are sudden releases of energy from the sun's surface. Increased solar activity can lead to solar storms and flares. These events propel energetic particles towards Earth at high speeds. The particles can interact with Earth's magnetic field. This interaction can cause auroras and disrupt radio communications. Earth's magnetosphere is an invisible, protective force field. It primarily functions to deflect the solar wind. The solar wind contains harmful radiation from the sun. By deflecting the solar wind, the magnetosphere shields Earth. This protection is crucial for life on Earth. Without it, the planet would be exposed to dangerous levels of radiation. The Earth's magnetic field guides charged particles from the solar wind. This guidance is especially pronounced near the North and South poles. At these poles, magnetic field lines converge and extend into space. Solar wind particles follow these magnetic field lines. The particles are directed towards Earth's atmosphere. This phenomenon contributes to auroral displays. Charged particles from space interact with Earth's upper atmosphere. These particles collide with atmospheric gases like oxygen and nitrogen. The collisions transfer energy to the gas molecules. This energy is then released as light, creating various atmospheric phenomena. Auroras are natural light displays in the sky, predominantly seen in high-latitude regions. They are caused by the interaction between charged particles from the sun and the Earth's atmosphere. These charged particles collide with atmospheric gases such as oxygen and nitrogen. This interaction results in the emission of light, creating the shimmering curtains and arcs characteristic of the aurora. The aurora's vibrant colors are a result of different gases interacting with charged particles. Each gas emits a distinct color when excited by these particles. Green is the most frequently observed color in auroras. This common green hue is produced by oxygen atoms. The green light emission from oxygen occurs at lower altitudes in the atmosphere. Therefore, altitude and gas composition are key factors determining auroral colors. Red auroras occur at higher altitudes in the atmosphere. These auroras are specifically caused by the interaction of oxygen atoms. The interaction involves oxygen atoms colliding with charged particles from space. This collision excites the oxygen atoms to higher energy levels. As the excited oxygen atoms return to their normal state, they emit red light, creating the red aurora. Auroras are natural light displays in the sky, predominantly seen in high-latitude regions. The vibrant colors observed in auroras are a result of interactions between atmospheric gases and charged particles. Specifically, purple and blue hues in auroras are attributed to nitrogen interacting with these charged particles. These interactions excite the nitrogen molecules, causing them to emit light at specific wavelengths. The emitted light manifests as the characteristic purple and blue colors observed in the aurora. Auroras are dynamic displays of light in the sky. primarily seen in high-latitude regions. The movement of auroras is characterized by flowing and dancing motions. These motions are driven by fluctuations in Earth's magnetic field. Incoming solar wind also influences and alters the shape and movement of auroras. The continuous interaction between these factors results in the aurora's constant state of flux. Auroras are most frequently observed in areas close to the Arctic Circle. These regions provide optimal conditions for viewing this atmospheric phenomenon. Norway is one of the prime locations for aurora viewing. Other key locations include Alaska, Canada, and Iceland. Auroras are typically seen in high-latitude regions. Strong solar storms can cause auroras to expand southward. This expansion makes auroras visible in areas where they are not normally seen. Therefore, increased solar activity can lead to more widespread aurora visibility. Space weather monitoring involves observing conditions in space. It focuses on solar activity and its effects on Earth. Scientists study phenomena like auroras to understand space weather. The goal is to predict and mitigate potential impacts on technology and infrastructure. The Aurora Borealis, or Northern Lights, is a natural light display in the sky. Auroras are typically observed in the high-latitude regions around the Arctic and Antarctic. They are the result of disturbances in the magnetosphere caused by solar wind. These disturbances cause charged particles, mainly electrons and protons, to precipitate into the upper atmosphere. The particles then ionize and excite atmospheric constituents, causing the emission of light. This visible light creates the dynamic patterns of the aurora, showcasing the connection between Earth and the Sunday.
Don't forget to click subscribe and join the family. There's so much more coming your way. Subscribe now and never miss out on the fun.